This is Young. Um, I am the instructor for software architecture and design for the spring semester of 2019. As promised, here's the lecture that I said I would record and share with you guys. A little bit about myself. I have been a software developer for about 8 years now. Not gonna bore you. You can read my introduction in the introduction discussions. But the majority of my career I spent working in backend system, developing primarily Java-based application for both distributed system for Fortune 30, 50 companies. I started out a C++ programmer for my first internship and was converted to a full-time Java developer when I was still a junior in college. Um, I'm currently is a senior software engineer at at Home Depot, and I have been there for 4 years. Let's get to it, right? So, software design architecture. Why is a good design matter? So, first of all, software design is the process that going to happen right after the requirement engineering phase. Obviously, the whole purpose of software design is so that you can find a solution into the problems that the business users ask you to solve. The problems are actually already have the solutions. The solutions are the actual system requirements that you would extract from the customers and officially or formally write them into what is called software requirement specification. So from a problem, you would extract exactly what the business user would need. You would then transform those high-level needs into the details of both functional requirements and non-functional requirements. You would store the result of your analysis and extraction into what is called software requirement specification. From the software requirement specification, you would try to create the actual system solution that will achieve or realize all of the requirements that the business user has asked of you. Why does a good design matter? Obviously, right? Similar to why it's important that you have the correct requirements from the users. If they give you any non-feasible requirement, you're not going to be able to design the system efficiently, or in a lot of cases, missing requirements or incomplete requirements will cause the project to fail. So similarly, it's important to have good software design because one, if you don't have a good software design, first you might not be able to actually successfully code or implement the product. Second, if your software design is bad, then that means there are a lot of then your design is vulnerable to risk and redo because a bad design not guarantee a long lasting system. You want a design where it's dynamic enough that all developers who looking at the design would be like, that's a good design. Whereas you know your design is bad if you give it to 10 software developers and they be like WTF. Alright, so I saw a meme online when someone go and review like code review, the less WTF you receive in the code review, that means you are a pretty good programmer, but the more WTF you receive, that means you are a bad programmer. Similarly, right? If people look at your design, they understand it, then that means you have a pretty good concrete design. Now, let's talk about the importance of architecture diagram. Nowadays, as we all know, software engineer is a pretty much a global profession. Not only people in the United States doing software engineering, but people from all around the world. Primarily, though, when you go work for a company, you may dealing with a lot of what their industry would call offshore people, meaning the actual development might not be done by you, but by people from other country who work in a different time zone. So like for example, there's a lot of contractors or offshore team who work in India. So because of the language barrier, right? If you if you write like a whole text document and give it to them, there's a chance that there may be some missing translation or the translation may be lost just due to a different language that they speak. So a good software design, I should just be able to hand them the design, the architecture of the system that we over here have developed, and they would just look at it and know exactly what you code or what you develop based on the design that you hand them. So in other words, you may or may not have already heard this UML universal modeling language. That is definitely one of the tools that you could use to communicate how you would like your software to behave or how you would like for it to be implemented. And there would be no question asked. You just hand them the design, they look at it, they understand it completely fine. There's no need for words, no need for anything, no need for translation. And that's why it's important to have software design, in my opinion. The number one reason is that there would be no misinterpretation of what the system should be doing. I hand them system to you. System has three components. System has a user login functionality or component. System has a backend component, and the backend is going to talk to the database. Then when you give your code back to me, I better see three different components in that design, and each of the components should behave as how I have it in my architecture diagrams. Right, you can read through these. Not gonna bother with these. These just require some reading. So I think this is important. Software design is the process that actually before the official SDS. After you have your requirement documentation, you need to spend time with primarily both your product manager as well as your software development team to looking at the requirements from a holistic point of view. For the product manager, he or she should look at it and trying to vision what exactly does the user want out of this product. So they would do what you would call software product design. Right? They would then communicate their feature or the need that the business user want to have to the actual software development team, where the software development team would come up with what is called software engineering design. So in the design sessions, it's better to have both the product manager and the software development team, and both personnel would work together to create the design. And whenever you feel comfortable about your design, that is when you would document everything in a formal document and then hand it over to both your business users and to your IT manager and see if they would actually approve the design or not. You need to also have the sign off, okay? Because, right, if you have everything in documentation, just imagine once you leave the company or the team, or even when you still remain, when new developers come in to join your team, they can just look at one, the software requirement specification to know exactly what the system should behave. Two, they can look at the software design document so that they know on a high level the different component that the system have, and in a lower level the detail of each component, how they were designed, how they were coded, and how do they communicate to one another. Alright. Alright, touch software product design, software engineering design. That's exactly what I told you. Alright, so this is my favorite part. Software engineering design. Lecture 2 pretty much also cover the same thing, except it's go more in depth over the responsibility of the software architect. Sorry. So for software engineering design, there's definitely two steps. One is the architectural design. or a lot of people would like to call it high level design. Step 2 is the detailed design or low level design. And there's a diagram that I want to show you. So this diagram is pretty much was what I had to study back for my undergraduate classes as well. Is basically it starts from you have the requirements. From your requirement, you would try to map each requirement to the actual solutions in your system. Each of these solutions represent the different component that your system may have, or is in academia term they like to call this module. So requirement one will map to module one. So for example, if the requirement one is the system shall authenticate user credential to make sure they are allowed to log into the system, then from that requirement, the translation of that requirement into module one, when you design the system, you would have a module or a component that deal with user authentication, right? And the functionality of user authentication would be to verify or validate that the user is actually registered with the system. Okay, so starting from requirement, first thing you should do is have what kind of modules you should have for that requirement. A lot of time you would group different requirements together and you would have one module that would be the solution for multiple of the requirements. But to talk a little bit more about architecture and detail design, for me, whenever someone say high level design, right, I would like to think of in terms of helicopter or airplane. You know, when you pretty high up in elevation or in the air, say you just fly somewhere and now you're returning back to Atlanta, you still up in the sky. When you're up in the sky and you look down to our beautiful city of Atlanta, you see that we have you can see how the roads are connecting together. You see that we have different lights, the road, the buildings, um, how each of those different components actually integrated together, and that's become the whole part of Atlanta. Atlanta doesn't just have roads. Atlanta doesn't just have street lights, buildings, but all of those together make up Atlanta. So from when you're high up in the air, you can see everything pretty below, but you don't really see how how the building was actually designed, how the street light actually programmed. You don't see the different street that your road would have. All you see is the road, the bridges, the lights, cars, all of that are different components, right? And then for your detail design, one, you actually landed in Atlanta. Now you see our airport. You see how many people there are. You see the different street in the airport. When you step out of the airport, then you see that you might have to go to a different terminal. So those are like the detail design for that one component known as airport. Right. So again, when you're pretty high up in the sky, you're in the helicopter, you can see how everything worked together to form what is known as Atlanta or Georgia. Once you actually landed at the airport, you see how the airport was built and designed. When you go out of the airport, you see the different street and roads, you see how they're connected together. You see how the traffic light work. You see the different street name. You see car. You see motorcycle. You see everything, and you know exactly the detail of each of those. You know the Starbucks building, you know the color of the Starbucks building, you know what next to the Starbucks building, you know what is 2 blocks below. All of those are the detail of each of the components that when integrated together again would form Atlanta City. Okay, so that's how I view architecture and detailed design. Pretty straightforward. So obviously this is an academia class, so if you want to use academia terms, then their high level design would be how the components or the modules link or work together to form that entire architecture of your system. The detailed design is how you would design each of the component or module. Okay, so that's pretty much it. Now for lecture 2, and bear with me for just a second. Yeah, that's not your test, that's just something that I write for fun. Oh, and don't bother Google your exam online because I'm the one who making them. Um, and I'm not going to quiz you based on memory, but more like based on your understanding. And I generally would give you a study guide before the midterm or the final, so you know exactly the format as well as what you should be studying for, or what I personally think you should definitely remember to help you later down the road for your career. All right, software architecture. Now this just talk about the different design strategies. Obviously, for each of the requirements that you have, you need to the first thing I always do is I try to group similar requirements together. Then I was trying to say, okay, what components should I make to deal with that group of requirements? All right. So, but if you recall from your software engineering requirement class, you have both functional and non-functional requirements. Functional requirements will dictate the behavior of your system. It's just a straight one-to-one translation. The system should do this. That means in your final implementation, your system better have that behavior or functionality. For non-functional requirements, they're usually dealing with attributes. Um, so for example, a non-functional requirement would probably be something along the line of um, their system database should never be down, or the system database should have an uptime, should have a pretty high, should have high availability and don't go down that often. So that non-functional requirement would, arguably translate to the attribute of reliability, right? High data availability. The system better be reliable. The system better not lose any data or lose connection to the database. I want for whenever the user log in, they can access the system. I don't want the system to be down. So for reliability, right? Obviously, you would then design your system differently. And in the next lecture, I will record some some tips on using jar.io, which is my personal favorite UML tool, and show you an example of mapping an actual requirements or non-functional requirements into an architecture. I'll just show you the different tips so that whenever someone say the database should never be down, and that non-functional requirement would translate to system reliability or high availability of the data. What kind of design should you have in order to sorry, in order to guarantee that you will achieve those two attributes of the system? I promise I have that done for the next recording. That is, if you recall what I said about high level design versus low level design, back to the helicopter, or while you're up in the air, all you see is the different components and how they interact with one another. But when you actually landed at the airport, you see how the airport was designed and built out. You see how everything are actually working together. You see the actual details, right? So architecture design are those that are visible to the stakeholder, whereas low-level design would be invisible to the stakeholders. Okay, talk about this. This also talk about the different responsibilities that the architect has. Okay, so I have a good news in regard to this. Is that I was able to schedule an interview with one of the software architects at IBM, I will ask him the generic questions about his point of view when it comes to software design and architecture. And you feel free to submit your questions to me. I will make a discussion forum where you can submit your question, and I will ask him directly for you. But on a very high level, though, software architect task. Before we even discuss software architect tasks, I want you guys to know that all software developers have the responsibility to design and architect their system, right? Granted, the software architect would be basically the design lead. Software architect are those that have experience with both their business domain that they're dealing with, as well as all the other existing IT system. They know how to integrate all of those systems together to form like like an IT network. So because I work in retail and retail industry, basically the architect, when you join an actual team, your team will more than likely be responsible for one system, but your system is not going to be the only system in that whole ecosystem at your company. So let's assume we are working in supply chain. For supply chain, obviously you would need procurement team, right? Where you go and make sure you have all the necessary parts in order to help you with assembling the product together. So that's procurement. You would also need a purchase order team where they would place the actual purchase against the vendor making payment, right? And you would need to also have a transportation management team where they would be responsible for making sure you have trucks so that you can go pick up the items that you order and deliver to the store so customer can actually walk inside the store and purchase the system. So already those are three different systems, and more than likely there would be three different teams to represent those three different systems. You would be in one of those teams. So the reason why I say all software engineers are also architects is because when you in your team, you are responsible for coming up with the design and the architecture of your system, just that system, right? And but the software architect is one who would look at all of the existing system or up and coming system and making sure they can integrate into the supply chain IT ecosystem without breaking anything. That's the main task of the software architect. Beside looking at each of the software engineering design architect for each of their system or the subsystem, he or she also need to be responsible and ensure that those subsystems actually working together to form what is called supply chain IT system. Okay, so that's the sub-architect. Now, in the discussion question, I asked you what is the difference between the lead developer and the software architect. Lead develop from like a hierarchy perspective, your career progression would be from software engineer to senior software engineer to lead software engineer, and then you have a choice between becoming either a software manager or software architect. If you prefer to pursue the management path, then you would be a software manager. If you still want to remain pretty technical, be like becoming like a technical guru, then you would pursue the software architect tasks. So the lead software developer is the one who would lead the design and architecture of his team system or of the system that his team is responsible for. And the lead developer will represent the team and work closely with the architect to make sure that the system that your team is responsible for will integrate perfectly into their existing ecosystem. Okay, so that's the biggest difference between architect and lead. Lead just lead the team and designing and architecturing the system for the team. But software architect look at all the subsystems and trying to integrate them, making sure they commingle perfectly fine. Okay, and that's all I have. Now remember, for next lecture, I will try to show you some of the design technique or how to basically translate the non-functional requirements or system attributes into actual design. I will also try to show you how to use drawer.io because you are expected to be doing a lot of diagramming in this class. And again, the reason why diagramming is so important, or from how I see it, is that you don't have to write a bunch of text to describe your system. All you have to do is hand somebody the diagram, they would look at it and understand exactly the system behavior or how to code it. This is extremely useful because software engineering is a global profession nowadays. You are expected to work with non-native English speaker or even where your teammate would not be located in the same geographic location as you. So there obviously would be some communication barriers, but with a solid and concrete software diagramming and design, you can just hand it to them and they would never make a mistake. Granted, their coding style or the coding may not be what you expected, or maybe bad or maybe better, I don't know. But at least you are guaranteed that you would have the same behavior as how you designed it in your software architecture diagram. Okay, that's all I have. Thank you so much. And please remember to go to the discussion that I will make and submit your question to me so I can ask the architect that work at IBM for you. Obviously, I will also record that conversation with him because he and I work at different company. It's going to be an online session where I just go through either well, if you submit any question, then I would go through your questions. Otherwise, I would just be asking my questions. But I will ask him for my question, your question, and also possibly maybe what they're looking for in hiring or what is the number one question he would ask any candidate that he interview for an entry level software developer. Um, is there won't be any assignment associated with any of the videos that I record. I just want you guys to have insight into how the real world work. This is also my second semester teaching, so if you feel like there's something that you're not getting out of me or getting out of this class, please let me know, and I will work one-on-one with you to ensure that you actually get in the knowledge that you need. Alright, thank you so much. Bye bye.